Good morning. Hello. Man, I haven't done a programming stream in like a week. Oh, it's so nice to have a break, but it's also so nice to come back. So, I wasn't really sure what I wanted to do this morning. I have a few things I need to do. First of all, I need to get C compiling on this computer. I installed Visual Studio on the last stream, but I also have a ray tracer that I want to finish up. So I think I might do the ray tracer first, and then we'll go from there. See if we get that done, and then maybe do the C programming. Just gonna be a short, like 2-hour stream this morning. So I gotta go do stuff in like 10 o'clock, 10:30. But should be able to still get some good stuff done. So yeah, I'm gonna do the ray tracer first. Hold on, I'm just gonna open up this shader on Shader Toy, and of course, because I haven't been on for a week, it's logged me on a Shader Toy. All right, here we go. Got a notification. It's just a conversation. Okay. So I can't actually remember what I called this here. Crystal Exhibit? Is that it? Yeah, I think it's Crystal Exhibit. So what I was working on was a shader I did a long time ago, a path traced shader of crystals. So now I have a new path tracer that's a lot better, so I want to redo this scene. It's basically a bunch of pillars with crystals with lights shining down. So this is supposed to be a diamond, but I just made it a cube last time. But we're actually going to go and make a diamond distance function for this. And then what I'm also going to do is I'm going to fix these lights so they don't just like look like white squares. I'm going to make it look like the light is reflecting down from something up above. So it actually looks like lights shining down. I don't know how to explain it. So it looks like basically skylights. The lighting is already good, but I want the light to be more directed and straight down. So to do that, we're going to go into our code here. We're going to go to the material code for the ceiling where the lights are, which is right here, the light emission. So what we're going to need to do is we're going to need to taper this light off in intensity as it goes at an angle like this, because if we're simulating the light bouncing around in a cube going up, if it's at the side, it's just going to bounce side to side, and you're going to get a lot less light. So how would I simulate that? I'm thinking maybe just a dot product. Maybe just a dot product. I'm going to try. So basically just scaling this by dot. Dot ray direction up. So we're going to compare the ray direction with up. So when it's going up, the light should be way brighter. So right here you can see it's sideways, and it doesn't get that much dimmer at the angle. So, So what I'm probably going to do is I'm going to apply a curve here. Pow. Try 4. There we go. So that sort of simulates the effect. Ah, man, it doesn't look real at all, though. I might actually need to simulate the light bouncing around. Or I need to scale the whole diffuse thing by that. Maybe if I go, so maybe if I do h.diffuse times equals, oh god. Okay, so if the emission is bigger than 0, and scale down everything. There we go. So that's a bit extreme, I think. Maybe we'll try 2. Yeah, so I think that's better. There should be a better way of doing this. There should be a better way of doing this. I mean, I could put holes in the ceiling. Something like that. Let me think about this. So it's not actually supposed to fade out the light. It's not actually supposed to fade all of this out. But yeah, to make it look like proper lights, I would need to put holes in the ceiling. I think I'm gonna just settle with this. I think that looks pretty good. It has a lot more direction going down, gives them a lot sharper shadows, which is really good. Okay, I'm going to keep this. And now I'm going to make this into an actual diamond. So I was just ray marking a cube before, but I believe I can actually customize this distance function to not be a cube but be a diamond. So we're not going to do any of this rotation. Anymore, at least. And okay, here we go. So I'm going to start with basically the same code as before, but only doing the X and Z. So this is going to be the square sides of the crystal, and then going up, I wonder if I should just copy exactly what I did before. So exactly what I did before was I didn't even program these crystals separately. I just made one distance function for the crystals that took in like rotation values, and it generated the crystals by rotating cubes and combining them and subtracting them. I'm wondering if I should just do that instead of programming each one. I probably should. So crystal procedural crystal distance function. So vec2s is going to be the seed. Or actually, I'm going to do options. So I'm going to do iterations. Then I'm going to do rotation. Scale, rotation, phase. Phase, frequency. So then I'm going to want to do a number of iterations like that. And my distance here. I'm also wondering if I should volume trace this. If I should be volume tracing this or sign tracing it. Because it won't have any density effects unless I do volume tracing. And that's the one benefit of the ray marking here, is that you can do the volume tracing. I'll probably end up trying both, I think, and then see which one works best. Alright, so I actually need to copy this cube distance function. I'm actually going to do unsigned first so that I can do the volume tracing. So that's just length max absolute value, position minus the size. I'm probably just going to make it a constant size, actually. Distance equals min. So to combine them with union. And then right here is where we're going to apply our actual deformation. So this is going to be rotating it. So actually phase and frequency are going to be that phase.x plus frequency.x. Actually, I should compute this beforehand. I might just do 2 rotations instead of all 3. Nah, I'll do all three. So after rotating that, I do absolute value. That will mirror it after rotating it. And that should be our procedural crystal function. So then we need to define the crystal parameters. So that will be I'll just test this one out first. One iteration, 0 phase, 1 frequency. Yeah, and I have transparency, so it's not passing through. So I'll need to apply the volume dither to it. Trying to find a good size as well. I think that might be good. All right, so the volume dither. Oops. Just one sec. I already forget how to use my own code. But this is why I gave an example of how to use it back here. And wait a second, I'm doing R2 point sampling here. Am I doing proper R2 point sampling? Because I actually did R4 point sampling instead of R2, and R4 is worse. Yeah, so I'm still doing R4 sampling here. God damn it. So I'll copy that. There we go. Now it's actually R2. Okay, so how do I do the volume dither? Yeah, so I just add the volume dither. Okay. Crystal. Guess I should also have a density. I'll just do plus volume D. Do 0.1 density to begin. Weird, it has almost like a wavy effect. And I don't think it's refracting even though it has refraction. Yeah, it has a refraction index. Maybe those waves are the refraction. Oh yeah, that definitely changed it. I guess the normal's messed up because the way it's so the volume doesn't support proper refraction. Because refraction happens when it enters the surface, not all the time. I think that might actually be the R2 sampling. It's causing that pattern. No, it's not. Hmm. I guess it's something about the volume dither here. I bet it's an issue with the volume dither. Let me try something. Try changing this to a hash. Syntax error. Oh, oops. Oh, there we go. So yeah, it was the hash as far as I'm aware. Or not using a proper hash. But still, how am I going to get proper volume? How am I going to do proper volume with refraction? Alright, sweet. There's none of those patterns anymore. Oop, got lost. No, yeah, it's a working transparent cube. So now I just need to figure out how would I get refraction in this. Right now it has 0 refraction. I wonder if it's because the volume is messing up the normal or what. Maybe I can't do the dither when I calculate the normal, or to calculate the normal wrong. Like maybe I have to do the volume dither in the ray marking function. I'm gonna try that. I'm actually gonna try that. Because the only thing I'm ray marking here is that cube, so I'm just gonna add that in right here. So what am I doing? Am I doing ray mark limited? Ray mark limited. Yes, I am. Okay. So I'll add right here to the ray mark limited macro plus volume 5. I might need to make a different version of these macros. Yeah, so this is still having pretty close to the same effect. Not having any refraction. Oh, that's because my refraction index is 1. Oh, okay, it actually changed a little bit with the refraction index. So it kind of looks like it's refracting, and it kind of looks like it's not. So it looks like there's a little tiny bit of a refraction. Actually, never mind. It's just being darker and harder to see. I didn't account for this. I didn't realize this actually didn't work with proper transparency. How could I do this? Maybe if I had the sign distance. So then here I could calculate the normal with the sign distance. Oh yeah, I just need sign distance. Okay, so I know what I need to do. I just need to have sign distance for the normal, and then do the normal just do the regular volume traces. So I actually don't need another macro. I can reuse this Raymark detailed macro with a custom normal function, and then I can use the signed distance for the normal. So this is just going to be a copy of this function, of the distance function, but I need to do sign distance here instead of unsigned. So that is, actually we already have the code down here. I think, oh, actually I deleted it. Never mind. Okay, so we already have the absolute value. That's the first thing you need. Then you need to subtract the size, which is 0.2. Then the first thing, I believe it's min 0 max x y z. So that finds the max distance below 0. So maybe, yeah, that's, I think it's supposed to be max there. Then next you, for the sign above 0 distance, you get the distance above 0 just doing length. max 0. And then that, oh, actually it's max 0 length. Like that, okay. All right, so now first of all, I need to add the volume dither back right here. Then Raymark detailed limited. Distance function. I pass in the normal function next right here, so that'll be, I need to create another macro for this, I guess. And with no volume dither. All right, that should be it, I think. So then I just do crystal 1n. All right, so there, it looks like there's a little bit of refraction right there. See the light going through whatever it's doing right there. Oh yeah, I have to do the signed. So it's definitely refracting light up there. It's interesting how it's not refracting light anywhere else here. So the refraction index will flip on the inside unless I do the absolute normal. Maybe if I do negative distance. Let me just make sure. Raymark detailed limited, crystal 1n. Normal F. Yeah, so it is using the custom normal function. Okay, so at the moment, I can actually see here, it looks like it's reflecting the wall. It's reflecting that back there. All right, so if I flip this, turn up the bounces because it's really dense. That's interesting. It's definitely looking like a volume. Definitely looking like a volume. You can see it refracting through there. So if I turn this down, we're back where we started with a little bit of non-refraction. Hmm. Hmm. Now it's always refracting because opacity is 0. Maybe it's because that refraction index is too high. Maybe it's not high enough. Oh yeah, that just made it more visible around the edges. Yeah, I guess I'm just not going to get super good refraction. Here we got a little bit of refraction. But yeah, as I turn it up, it actually goes away. There's the absolute distance here actually better. Yeah, it does not support refractive surfaces good enough. All right. Well, I guess I'm going to settle with that. I got my crystal function, so I'm choosing between refraction and volumetrics. I probably want refraction in this, I'm thinking. So I'm going to make this the crystal distance function and do signed tracing. All right, there we go. So now I'm doing the material. I think I want to give it a little bit of a green hint. It's going to be completely clear. It's going to have a little bit of a reflection. There we go. That's nice. That actually looks like a decent diamond or crystal. So now I'm going to actually set up the crystal parameters. So first of all, the phase and frequency are equal with one wave like this. So just try some yaw to begin. Undetectable. Well, okay, so a little rotation like that. So it's not actually doing the distortions I want. So I think I'm actually supposed to do absolute value right here instead. Yeah, there we go. So that's interesting. That looks like a diamond or something. All right, so that's the type of shape I'm looking for. So that's awesome. There's my first one. I'm going to place it down closer to the ground now. I'm actually also going to increase the light intensity because I want it to be a little bit brighter. Okay. So if I want to move it down a little bit, I think I do 0.1 right here. Yeah. Awesome. Yeah. So now it's right against there. You get that reflection off the surface. That bottom. That's amazing. Seems like there's a little bit of non-repeating or a little bit of artifact right there. I'm wondering if it's the R2 sampling. Yeah, I think it is. Damn, I think it is because it seems to clear up from the noise function there, but it doesn't clear up in the R2 sampling. I guess they'll clear up eventually in the R2 sampling. Alright, so now to do the next crystals. So the next one I had the one like I really remember is I had this shining green crystal. It was super bright, so it basically sent green caustics everywhere. Wondering if I should point these lights more downward too. Probably give a good effect, so I might. I'll place the crystals first. Okay, so let's make the next crystal. I went to go make all three at the same time, but decided not to. Just in case I make any changes to this, I don't have to change all of them. So I'm going to put this one beside on the X. How am I going to change this one? Oh yeah, I said this one was going to have little refraction, and then I gave it this big refraction, so is that actually just the reflection? I think it's actually just the reflection. Yeah, it is. Damn. So let me make sure this crystal is absolutely good. Just that little bit of refraction, a little bit of reflection as well. All right, I think that looks good. All right, bright green. I'm going to put this one up in the air so it's a little bit so it's not intersecting as much. And I obviously got to increase the steps because it's running out of steps right there. I'm going to do 24 and 32, I guess. All right, so first of all, I'm going to design the shape because I don't like this shape right now. So go to my crystal 2 right here. So I may end up using 2 iterations, but I'm going to see if I can do it with just one. But of course, the more mirrors I get in it, the more complex it will be, and that'll be very nice. So, but the issue with this is that it has more iterations, more ray marking steps. So doing also more iterations will be alright. Yeah, I'm gonna try more than one iteration. Yeah, I like that. Let's place it so it's right down on the surface. So I'm going to shift this offset down. There we go. Just like perfect. All right, I got to do the material for this now. This one's going to be a little bit rough. And it's going to have a much bigger refraction index. I may also want to flip the refraction index in and out. I'm not sure. We will see. I mean, I should try flipping it in and out. I already think it's looking pretty good, though. Get the green one through this one. Nice. Alright, so yeah, I'm going to reduce the roughness. And I'm going to try flipping the refraction index. Can't remember, do I do that here? I think I did end up flipping the refraction index in the prism here. Prism. No, I didn't end up flipping it. Okay. Alright, so, I don't know how I'm going to do this yet, because this is made to return absolute distance. Oh, unless I do crystal sine crystal U. Actually, I do it right here, so I could just do crystal 1u. So it'll return the signed distance. But then I'll just create this macro to do the unsigned. Make sure. It actually seems like I broke something there. Did I? I don't think I broke anything. Oh, I just did it with crystal 1 and not with crystal 2. So crystal 2 is busted. Let me actually make sure. So I gotta do crystal 2u. Alright, there we go. I don't think anything is busted actually. Okay. So now if I want to flip the refraction index, and create a macro for it. Flip refraction inside crystal. If distance smaller than epsilon, smaller than 0, it's inside. Flip the refraction index. So I'm going to try it with this one first. R flip crystal 1. I think I'm going to need to get the hit position, so I need to pass the position into this, I guess. Or I can just do df plus d times h dot normal dot w. Or actually, should I just do s dot w because it'll be right there? Probably s dot w. All right, r flip crystal 1. How much different does it make it look? It looks exactly the same. Huh. Is it not flipping? Maybe I have to do smaller than epsilon. All right, I'm going to put some music on as well. Wait, there's like static. Is that showing up on OBS too? It's like my audio drivers are bugging out. No, it seems like it's good now. Huh. That's weird. Refraction index equals flipped refraction index. If smaller than distance function, result smaller than epsilon. Alright, so I'm inside it. This should help me test if it's actually flipping. If I disable this, it should change. And it's not changing. So that's what it should look like. Okay, so it's not flipping. Oh, it's because this has the position. This has the position. Crystal 1 position. So I can use that right here. Nice. There we go, now it's working. See how that looks. Well, I think that's more correct. I'll try doing it on this crystal. I wonder, I'm curious how much chromatic, how much focusing of light there is. I think it'll be much more visible with the green one if I do this. So I might not do the flipping there, because it doesn't look better. It looks worse. So I am going to do this with the second crystal though to test. So our flip, crystal 2 position. I'm wondering if that makes it focus any green light anywhere. also seeing these lines here. I'm wondering, this must be an issue with my hash function. Yeah, so it seems like flipping the refraction index doesn't really make that much of a difference. I should probably do it just for correctness, though. So let's check out this hash function. Yeah, it seems to have noticeable lines. I'm going to delete the parts that I don't need here. And I'll do that afterwards. I still need to... I wonder... I should probably spend the time to fix this noise function. So there's definitely lines there. I wonder, did I end up changing the noise function around? Just like how I changed the R2 sampling and didn't switch that. Oh, I did. Let's see if this works better. This looks like it has bias. On this area close to the camera, it looks like it's biased towards a certain pattern. The main question is, will this converge over time, even if it's noisy like this? Will it end up smoothing out? So I think I either need to increase the number scales here I think I'm going to rewrite this. Check something. What's 1 divided by pi? Alright, I think that's a good seed value. So all of this starts with A. YZWX. Oh god, it's horrible. The fractional value of those times a very little value, so this just adds seeding. Then, because it handles positive and negatives, I'm going to do sine. And maybe cosine, so that it starts at 0.5. You know what? That actually didn't render out too bad. That actually seemed to even out pretty nicely. Is fract actually a valid random number generator for path tracing? Oh my god, look at this. What is this? It's actually converging. That's so weird. Alright, let's try adding our cosine wave. So the plan with this is to get the higher frequency noise. Because it's going through a cosine and it's wrapping around, it shouldn't really matter how big the number is, as long as it's not infinite. Times 100 divided by pi. And when we add this, we do times 0.5 plus 0.5 times 10. Actually, times like 20. So that way it'll loop around. Alright, that's not enough, so we'll try scaling it by 1,000. Scaling this by 1,000 as well. Actually, should probably scale this by like 100,000 now that I think about it. I want it to actually be noisy. Oh my god, I actually think it's working. Whoa. So except for the ceiling here, it's actually rendered very nicely. I don't think it's random enough though. I'm wondering what's happening here. So I believe I actually have to do different frequency waves here. Oh, that looks pretty good. And that just uses different frequency noise. I might increase that. It's that as well. It almost seems like that 1,000 is way too much or something. I wonder if this is too high frequency. Oh, that actually looks really good. I think that's it. Now we'll test and see if this converges. I'm wondering if it's going to stay a little bit biased like that, though. I think it's smoothing out, but it's really hard to tell after a certain period of time because it starts slowing down so much. it's done. Seems like a pretty good noise function though. Yeah, it looks like it converges pretty well. Awesome. Alright, let's move on with the next crystals. Alright, that's nice. Now let's do the third crystal. Actually, you know what? I want to try pointing the lights down more first. That should just be increasing the curve here. Make the lights more pointed down. But then it makes the lights look a lot worse. Maybe I will do actual holes in the wall for lights. Maybe I'll increase the ceiling's height so you can't really see instead. But now the light's a lot more diffused, damn. I think I'm just going to settle with those lights because it looks good. Just not when you look up the ceiling, but it's not about the ceiling. It's about the crystals. So, let's do the next crystal now. I don't even think I'm going to flip the internals of the crystal because it doesn't seem to make any huge changes. You know what? I put in the work implementing this. I might as well flip the crystals. Alright, so there's crystal 3. So there was also a yellow crystal and a blue crystal. So I guess I'll do the yellow next. Oh, damn. I deleted those and I'm supposed to have kept them. That's purple. That looks even better. I might just do that instead of the blue. Or maybe I'll do like a purple blue. Like that, yeah. Alright, now let's design the actual crystal. So to design it, I like to set them to opaque so that I can actually see the material more like this, see the actual shape. Let's change up the shape a bit. So crystal 3's shape is right here. I might just do another one iteration one. Nah, so that's looking the same as the diamond. Alright, I might do that. So, alright, let's lower it down to the surface now. There we go. Perfect. Look at that path tracing. Hell yeah. Alright, now let's do the material. I think I'm safe to delete all this old code now. Alright, now for the last one, yellow. Right, and now here's the fourth final crystal, yellow. Oh, I forgot to move the position over. There we go. Oh, look, and you can actually see the light reflecting off of it. It's nice, it looks gold. Okay, so this one I think I'm going to do 2 iterations. That's an interesting one. That's cool. Maybe I'll actually do one with 3 iterations. Let's see. Maybe I will. Just because it's cool. Alright, now to do the proper material. Well, you can see the green through the yellow. Maybe I'll do a major refraction index. Alright, now let's find a camera position. Maybe like right there, I think. I might actually want to move them closer together. Alright, I think that might be just a little bit too much refraction. You can't even tell what's happening. What are those black lines that just showed up? I guess those are bounces. So I need at least a little bit of opacity to fill in the light there. Maybe that'll be my camera. Or maybe over here. Not sure if I want to keep the pillars floating. Very nice. I'm going to try copying over this hash function and see if it works just as well here. Also need to copy the volume dither back over because I deleted that. Oh yeah, that's way better. Alright, let's release this shader now. I'll do a little change of the camera direction. Now, you know what? That was actually nice right there. I'll do a full screen. That looks nice. Pretty happy with that. Let's go exhibit. Old scene I just fixed up. Make sure everything's good here. No important sampling. Alright, I think that's good. There we go, crystal exhibit. Alright. So I'm going to post that in chat. If anyone's interested in this, you can view the shader right here. I'll also be posting that on Discord. Alright. That's going to be the end of this stream this morning. Man, I'm happy to have that path trace scene done. There's some other shader stuff I want to move on to, but it was bugging me that I didn't finish that crystal path trace scene, so now that that's done, yeah! Now I can move on to other things. I'm probably going to do a stream of C programming later. I'm not sure. I might actually do some more shader programming because I'm addicted to shader programming, but I don't know. We'll see. Anyways, this was a good productive stream. I got that done. I released that. I'll be back in like, I want to say 3 hours at like 1 p.m. EST. Not going to make any promises though. Yeah, that was the stream this morning. Thanks to anyone who stopped by and watched. If you have any questions, I'm going to keep talking on Shader Toy and talking on Shader Toy. What am I saying? I'm going to keep talking about this stuff on Discord. If you want to get notified of the streams, you can also join Discord because I say whenever the streams are live there. Anyways, thank you for watching. I hope you enjoyed the stream. Hope everyone has a good day. I'll see everyone later.